Perfect. Solving for C. And as you already said, you already think it's equal to 15. That's not always the case, but we'll see. Okay, dy dx equals 2x. And the antiderivative becomes x squared plus c. This is the general solution. If we're given more information, we might be able to solve for c. So here we have f prime of x equals 3x, and you know that the original curve passes through 2, 12. So first of all, we can integrate and say add 1 to the exponent and divide plus c, where c is any real number. But now the fact that we know that it passes through the point 2, 12 means that when x is 2, y is 12, we can plug that in. And from that, solve that c would have to be 6. No problem. And so now we know the actual equation for f of x is 3x squared over 2 plus 6. Unfortunately, it was not 15.
You should have done it as 15.
I should have done it as 15. Here, I'll go like this.
Full screen. Mr. Roth, if you want to be showing them, make it full screen as well.
The gradient of a curve at the point xy is 16x cubed minus 3 over x to the 4 passes through the point 1, 4. Can you find the equation of this curve?
So gradient means first derivative, right?
Gradient means the slope. And since it's giving you the slope at a general point, it's basically giving you the derivative, just in a different way. Zoom. C is equal to -1. So first you can integrate, then you get your plus c, and then since you know it passes through the point 1, 4, when x is 1, y is 4. This is good. Integration, no problem. Related rates, let's not talk about it. Integration, no problem. Yeah? Not happening. Okay.
Don't give up. Let me do that for you.
We also have some times where we have equations that have a d and a c. If you would start with your second derivative and have to work your way backwards once, you'd have a plus c, but then when you work your way backwards again, you might have a plus d.
Why not a plus E or B?
Or you could if you wanted to go super far, but usually second derivative is about as far back as we'll move up. See if you can interpret this question. Work your way backwards to the first derivative with a plus c, and work your way backwards to the original one with also a plus d, and see if you can find the original equation of the curve. Okay? Everybody's ready? Okay, first part. So if you were working backwards, you get the first derivative from the second derivative, and if you plug in the fact, okay, this is the part that's hard, it tells us that the gradient of the curve at point P is 23. Now, that tells you your slope, but it also tells you your slope at x equals 2. So you get the original x values at 2, and the slope will be 23, and then you can solve that c has to be 3. dy dx is 23 at that point, so at x equals 2, you can put that off to the side here. What this means is at x equals 2, dy dx equals 23. And then once you have that information, we can integrate again. And we have to use a different letter because c already represented something in this question. I'll wait for a second. Now you can plug in 2 and 13. So you can see the difficulties you might have is just plugging in the wrong values at the wrong place. And the hard part is seeing that you can plug in x equals 2 for when the slope is 23.
For the second coefficient, what do you apply by negative?
For this one here,
No.
it's good? Okay.
Perfect.
Okay, and I can move down a bit. So then, solving for d, you get minus 5. And now we can write our original equation. Y equals 2x cubed minus x squared plus 3x minus 5.